In section 4.2b, we are going to be working with standard form and vertex form, and we're actually going to figure out how to change a standard form quadratic function into a vertex form quadratic function. So let's just remember which is which. Remember that standard form is the one that goes y equals ax squared plus bx plus c, and vertex form is y equals a times x minus h squared plus k. Now the handy thing about vertex form is that we can tell some pretty good information right off the bat. We know that from the h and the k, the h tells us whether we shifted left or right, the k tells us whether we shifted up or down. And this is called vertex form because we can find the vertex by using those shifts and immediately know where it's at. The vertex would be at hk. And then we can tell how to graph it by looking at the number in front. It tells us whether there's a stretch or compression. And it also tells us if it reflects over the x-axis, if that number is negative. Now, standard form, you also can tell if there's a stretch or compression. And if it reflects over the x-axis, if it's negative. So that part's the same, but I can't tell the vertex right away. Remember, to find the vertex, I have to do that opposite b over 2a for the x-coordinate and then plug it in to get the y-coordinate. But what I can tell right away is the y-intercept. So both forms kind of have information that you can tell by looking just at the equation and not doing too much work. But one of them is definitely easier for graphing. So think about that for a second. Which form would be more useful for graphing? Remember that in order to graph these parabolas, we're going to use the growing pattern and then multiply it by the stretch or compression. And we also need to know the vertex. So if we are going to be graphing a parabola, the easiest form for graphing is when it's in vertex form. Because right away we know where the vertex is and we know how to change the pattern to make it work with the stretch compression or the reflection. So what we want to do is figure out how to change a standard form into a vertex form. So I'm going to give you the steps along the left side, and then we're going to work on an example over to the right. So in step 1, we need to know what is a. A is the number that's out in front of the x squared, so we'll be able to know that just by looking. So let's do an example over here. Y equals negative 3x squared minus 18x minus 10. So in this case, a is negative 3. Easy peasy. Step 2. We need to know where is the vertex. And in order to know where the vertex is, we're going to have to do opposite b divided by 2a for the x-coordinate, and then plug that number in to get the y-coordinate. So we'll do that for our example. So x would be the opposite of b. b is negative 18. So positive 18 divided by 2 times a was negative 3. So that's 18 divided by negative 6, which is negative 3. And then to get the y-coordinate, we have to plug negative 3 in to that equation. So y equals, that's the negative 3 that was already there. And then instead of x squared, I'm going to put parenthesis negative 3 squared minus 18 parenthesis negative 3 minus 10. We keep working that along. So we'll have negative 3 squared makes positive 9. So I have negative 3 times 9 minus 18 times negative 3 minus 10. And then multiply these numbers. Negative 3 times 9 is negative 27. Negative 18 times negative 3 is positive 54. Trust me on that. And then subtract 10. Now remember to check to make sure these two numbers, one of them is twice as big and they have opposite signs, so we're good to go there. And then we're going to add negative 27 plus 54 is 27. Subtract 10 gives me a y value of 17. So my vertex would be at negative 3 for the x-coordinate, 17 for the y-coordinate. Then the next thing I'm going to do is I am going to use the letter that I found for A and the vertex, which I'm going to represent by HK, to write the equation in vertex form. So that's going to be y equals the A that I found at the beginning of my equation times x minus the h from the vertex squared plus the k from the vertex. So, looking at what I had found over here, there's the a value. A is negative 3. And then from the vertex, h is negative 3, k is 17. So I am going to write that into vertex form by doing y equals the a value, which was negative 3, times x minus h, which was negative 3, squared, plus k, which was 17. Now I don't want to leave that x minus negative 3 because that looks kind of funny. So I'm going to go ahead and fix that and make it y equals negative 3 times x plus 3 squared plus 17. And now I've changed my graph from standard form to vertex form. Okay, we're going to practice that again in a second, but before we do, I want to talk to you about finding the y-intercept and how to do that in standard form and in vertex form. So, now which form is easier to find the y-intercept? Standard form or vertex form? Remember, in standard form, the y-intercept is right there at the end. So we're going to use the example that we had been just working on, and we're going to find the y-intercept when it's in standard form, and then we're going to find the y-intercept when it's in vertex form, and those two things should be the same. So remember, when it's in standard form, y equals ax squared plus bx plus c this number right here, 0c, is the y-intercept. So from our example, which was y equals negative 3x squared minus 18x minus 10, our y-intercept should be at 0, negative 10. Now in vertex form, which was y equals a times x minus h squared plus k, the way we're going to find the y-intercept is we are going to sub in 0 for x. So this is going to be a bit more work. So from our example, we had y equals negative 3 times x plus 3 squared plus 17. So we're going to sub in 0 for x. So y equals negative 3 times 0 plus 3 squared plus 17, which makes negative 3 times 0 plus 3 is 3, and then 3 squared would be 9 plus 17. Negative 3 times 9 is negative 27 plus 17 gives me negative 10. So the y-intercept, when I have it in vertex form, would be 0 for the x-coordinate, negative 10 for the y-coordinate. So you see we get the same y-intercept. It's just a little bit more work there. As promised, we are going to practice changing to vertex form again. So we are going to change this equation, this quadratic function in standard form, into a quadratic function in vertex form. So y equals negative x squared plus 5x minus 12. Now remember our steps. Step 1, we had to say what a equals. Step 2, we had to find the vertex. And then step 3, we do y equals a times x minus h squared plus k. So we're going to go through all those steps for this function. Well, a is the number in front of the x squared, and even though there's no number there, it's assumed that there's an invisible 1, so a is negative 1. So we'll go ahead and put that in there. And then to find the vertex, remember we do opposite b divided by 2a, and then plug that number in to get the y-coordinate. So the x-coordinate of the vertex will be the opposite of b, which is 5, so negative 5, over 2 times a, which was negative 1. So the x-coordinate is 5 halves. So go ahead and write that, 5 halves. And then we have to plug that number in, which, I mean, it's a fraction, so don't panic, just keep your wits about you and we'll make it happen. So we're going to have negative, and then we replace the x with 5 halves squared. It's important that that negative symbol stays outside the parentheses because the only thing that's being squared is the x, so I'll have to square my number first and then apply that negative. So then I have plus 5 times 5 halves minus 12. So that's going to be 5 halves squared. Basically, I'm going to do 5 squared and 2 squared. So that's going to be 25 fourths. And then I put that negative out in front. So negative 25 fourths plus 5 times 5 halves. That's like 5 over 1 times 5 over 2. So I do 5 times 5, 25. 1 times 2 over 2. And then minus 12. Now, in order to be able to add these fractions, they need common denominators. So I'm going to need to get a denominator of 4. So I'll need to multiply this times 2 and the numerator times 2. And then remember that 12 is really over 1. So I'll need to multiply 1 times 4, which means I need to multiply 12 times 4. So now I'm working with negative 25 fourths plus 50/4 minus 48/4. Now remember, these two numbers should be one twice as big in opposite signs, and that's working out for us. And then we'll go ahead and add the numerators. We keep the same denominator of 4. So negative 25 plus 50, which would be 25, and then subtract 48 would be negative 23/4. So that's the y-coordinate of our vertex, so we'll put that in the y-coordinate of the vertex. And then we just start replacing our numbers. So I'm going to replace the a with a -1, the h with a 5/2, and the k with negative, let's make it 23/4. Negative 23/4. So the equation I'm looking for is y equals, I don't have to write the -1, I can just put a negative symbol, and then x minus 5/2 squared, and then I don't want to write plus negative 23/4, I'll just write minus 23/4, and that will be vertex form. Okay. I am going to kind of cheat on this one because we're going to be making a sketch. So I'm going to cheat and use a Post-it note that's graph paper. Sorry about that. But I'm still doing it. Okay, so we are going to sketch the parabola that has a vertex at -3, -1, and goes through a point -5, 7. So I'm going to talk to you about how to do that. First I'm going to put my axes on here. And since my vertex is at -3, -1, I'm going to give myself more space in the negative side. Quadrants 2 and 3. So the way that I'm going to make this happen is that I am going to plot the vertex on my graph. My vertex was at -3, -1, so I'll go over to -3, -1. Then I am going to plot that other point. So it's going to be my next thing. Plot the given point, which was -5, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So there's my vertex, which was at -3, -1. And here's the point I was given at -5, 7. And then the next thing that I'm going to do is, since these parabolas have to have symmetry across their line of symmetry, I'm going to go ahead and sketch the line of symmetry. Now, if you remember, the line of symmetry is a vertical line that goes through the vertex. So that's going to be a vertical line that goes through my vertex. And I usually draw those as a dashed line. So there's my line of symmetry. And it happens to be at x equals -3, if you need to know that, because it goes through the x coordinate of the vertex. So x equals -3 is its equation. And then after I do that, I am going to plot the mirror point that I would have due to symmetry. So this point right here would have to be reflected across that line. So if I just go straight to that line, I'm going over 2 spaces, so I would go 2 more spaces, and right here is the mirror point. And then voila, I have enough information. 3 points is enough to sketch a parabola, so I will sketch the parabola. So remember, we want to kind of make it a smooth curve through the vertex, like not pointy. I'll do my best. Curve through the vertex and then through the points. Make it nice and tall and give it arrows on the end. We have one last problem to do in this section, and it's this guy right here. This is going to be kind of a thinker. We are supposed to be able to find b and c for this equation, y equals negative 3x squared plus bx plus c, where this parabola has a vertex at 1, 5. So we're going to have to kind of think backwards on this problem. Like, instead of asking us to find the vertex when we have an entire equation, they're giving us part of an equation and a vertex. So we are going to have to work backwards. So let's think about how we find a vertex. So here's my vertex. How do we find this? When the equation is in standard form. Remember, in standard form, we find the vertex by doing opposite b divided by 2a, and then we plug the number in. Well, they've given us that x equals 1 in our vertex. And I know to find the vertex in standard form, I do x equals opposite b divided by 2a. Well, I also happen to know what a is, but I don't know what b is. So I am going to take my x equals opposite b over 2a, and I'm going to replace the x with the number 1. So I'm going to say 1 equals, I don't know what b is, so I'll have to keep it opposite b. I do know what a is, over 2 times negative 3. So 1 equals opposite b divided by negative 6. And then I can go ahead and multiply both sides by negative 6. So negative 6 equals opposite b. So b would be 6. Okay, so that's part of my answer. 6 is my b value. Now, how am I going to find c? Remember that in standard form, c would be the y-intercept. So I think what I can do is use my vertex and my stretch with my reflection to rewrite my standard form into vertex form. So that's what I'm going to do. I'm going to rewrite in vertex form. So that would be y equals, remember I used the same value for a, so negative 3, and then I do x minus h, which is the x value here, so x minus 1 squared, and then plus k, which was 5. So then, in order for me to find the value of c, which is my y-intercept, I'm going to find the y-intercept. And remember, in vertex form, what we do is sub in, so 0 for x. So now I'll find the y-intercept by subbing in 0 for x. So y equals negative 3 times 0 minus 1 squared plus 5. So that will be negative 3 times negative 1 squared is 1 plus 5. So that's negative 3 plus 5. So y equals 2. So my y-intercept would be 0, 2, which means that c, which is the y-intercept, has to be 2.